Okay, we can look at the stages of the development life cycle. I'm going to give you an overview about this. So one of those stages is, as you are aware, the S-curve. Why do we care about S-curve? What does that allow to occur? Well, it helps businesses when it comes to looking at economic benefits. i.e. looking at trends, etc. So those economic benefits, we should be able to see initial slow growth of a product, visits where basically it grows in popularity, so gains more customers. I do cost for customers. So business growth is slow because it's new. I do an arrow pointing to gains more customers. Develops more products. Which allows a business to build foundations. So the S-curve will plan for initial slow growth. So you're a new business, you start creating more and more products. Those products will gain you customers. Those customers will help you develop even more products, which allows you to build some sort of foundation, which will help your business grow. So I'm going to put growth scale. You then have rapid growth. This is basically where a business experiences rapid growth as customers, so I'm going to do cost for customers, learn about the products. So I'm going to do 1, I'm going to do 2. You then got late stage growth, which is basically companies are experiencing slow economic growth. I should say M, and that's an M. My hat's hurting, so economic growth. And basically take countermeasures. Oh, go away. So this could be these countermeasures to tackle this slow growth, releasing new products. So I'm going to do new prod for new products, or looking at market shifts, going into new markets, looking at new areas for them to hit. You then got what's called stationary demand. Where growth or product demand is static or decreases. So it's fizzled out. So companies can either So what can we do? Adapt by innovation. That means creating new products or methods, or reshape. Well, you can actually classify reshaping as adapting, I guess. So I'm going to put reshape their business structure. So that basically means, I'll explain that in a second. So you can have a business where you've got loads, and you have an owner, you then have like managing director, a managing director, and a managing director. You then have people working under them, people working under them, people working under them, who then have people working under them, people. So change your business structure might mean, okay, let's get rid of all of these people and let's change our structure. So instead of these being managing directors, let's give them like all the same responsibility as a team, rather than having different managing directors responsible for different areas. It could mean creating infrastructures whereby, to reduce costs, you might outsource. So you can have some people working, then you have an outsource area, which is cheap labor, working with the company. Who knows? But that's another thing. You can reshape your business if you've got stationary demand, or move to new product. So you've got innovating new products or just moving to a new product. Innovating is like designing. Moving to a new product is just going ahead and doing it without the innovation aspect. So, S-curve gives us an economic benefit because it allows businesses to basically plan out the next moves. If you identify yourself as having slow growth, you then know what to do next. If you've got rapid growth, you know what to do next. Late stage growth, all of these aspects, it allows businesses to know exactly where they are at. Now, if we're talking about the S-curve, which is what we're doing, we know that the S-curve looks like this. With 4 stages, and we know about these 4 stages. I'm not going to go into any detail about the 4 stages. So you've got your 4 stages. You've got the very fact that the S-curve can provide economic benefit, but it also allows us to classify. So really, you can say these are connected together, and from this we can classify user groups that take up new tech. So we've got our innovators, we've got our early adopters, we've got our early majority, and we've got our late majority. So not only, laggards. So we know that innovators are those who are willing to take risks, try new things. We know that early adopters are the people who gather information and personal experiences with technology before they're recommending it to other people. They're the sort of people who want to look trendy, the sort of people who have the latest items to look cool. Early majority are the people who quietly test out things before buying it. Basically, they'll try things out, they'll give a case study for it. And basically they go to the early majority with evidence of what technology can accomplish. So these are the sort of people who are more research informed, whilst early adopters other people who are more about looking at other people's personal experiences before buying it. But they're still about looking trendy, whilst early majority is more about using case studies about what tools can do with evidence, and then go ahead with more of a pragmatic approach. You've then got late majority, which they don't like risks. They're the sort of people who don't like change. If you've got an update on your phone, these are the sort of people who will snooze it and not bother to update it. They don't see the point. They need solid proof before buying anything. And then you've got laggards who prefer the status quo because they know what to expect. They're the most stubborn people. They're the people, what's in it for me? If I get this, what's going to benefit me from it? There's a difference between late majority and laggards in respect to laggards are harder to convince. They get frustrated by technology. Late majority are just more needing a bit more convincing and proof. Okay, so if we zoom out, all of this is the S-curve. It can give us the economic benefits to support business development and business growth, help them identify. It allows them to use the different phases of the technology development. Again, helps them with knowing when to sell, knowing when to change, supporting those economic benefits. By classifying different users, it allows different targeting, different marketing, or target marketing, shall I say. So, S-curve is the stage of development life cycle in terms of from an economic perspective. But now let's look at things from a development perspective. So if we're developing software, we need to be aware of these different phases. Feasibility, requirements, design, software development, testing, and release. So we know a lot of information about this already. We know that feasibility study is about economic feasibility, time, political, legal, all of these things need to take place. Requirements is interface requirements, functional requirements, performance requirements, like the wish list. Design, hardware and software choices, data structures being used, input design, output design, storyboarding, all those aspects. Software development, like version management, documentation, standards being put in place so that the product is developed safely and securely, and choosing the right method. Testing, white box, black box, alpha, beta, end user testing. And then you've got release, which is changeover. And remember, this is our big mark question. In order for us to do development, we need to have a team. In our team, you would have an owner, you would have an engineering manager who's responsible for the development of the whole life cycle. They're in charge of the scope, planning the project, the progress, making sure that everyone's working together. They manage the software engineers. We then got software architects. These are people who know the internal structures of the programming, the technical aspects. They need to have high programming knowledge, but also leadership. They're responsible for managing and motivating the developers, the architects. Their role is to help the developers keep things simple and maintain quality. So So these guys are basically bosses of the software developers. If something's developed and it's poor quality, it's the architect's fault. Software developers are responsible for building. They're responsible for tackling logical problems found whilst programming. And that'll be a team of different people's strengths. You then got, I'm going to do a bridge over here, UX and UI designers. And we know very well that UI is the user interface, UX is the user experience. The user experience is all about how the software behaves and communicates with the user, and how easy it is to understand an interface by just looking at it. Remember, user experience is a big mark question. You then have QA engineers. These people are responsible for testing. They look at the processes, they ensure that everything's followed through. They're absolutely vital to ensure about high quality products. You then got the business analyst. So the business analyst is in charge of assessing and analyzing what the client's business needs are. So you turn the requirements that you get at this stage and turn it into something which is easy for our programming team to work with. It's not easy, but it's absolutely fundamental for this stage. So it's like bridging the gap between business and geeks. So you should be able to understand how each one of these roles relates to the development steps that we looked at, such as feasibility, requirements analysis, design, software development, testing, and release. Now, with our development, there are different methods of what we can take. We could use the waterfall model. We could use RAD, Rapid Application Development. We could use Agile. And we could use Big Bang or Spiral. So we know of waterfall, steps in order, that each step needs to be completed before the next one is done. You have a handover document after each step. Step complete, handover. Step complete, handover. Step complete, handover. It's great for large projects. Great for large projects. Perfect where requirements are essential to be understood. It's poor for dealing with change, or I'm going to do like a little dot, requirements not understood. You then got RAD, less plan, more adapt. Remember, it uses prototypes instead of design. So, no design. Docs. Great for user interface, because the whole point of user interface is that you want quick feedback from people to make changes. So the advantages Let me just move this across. You can argue that software more usable, that the developers focus on the business problem. So the focus isn't on geekiness, it's on, remember, keeping the end user informed. Is this good? Do you like it? So you're constantly talking to the business, the end user. Key risk factors can be identified and adjusted quickly. So if you're developing something using RAD, you can spot problems and solve them straight away. Early in process. Whilst waterfall, remember, you might be near the end where you spot a problem. So because of this, less catastrophic failure. But the disadvantages, I'm going to do that in red. Lack of non-functional requirements. So these are things which might not be demonstrated in your prototype. And poor design can lead to system architecture issues. So what we're basically arguing here is that by rushing things through, by using prototypes might not capture everything about your product, like the non-functional requirements. That, and by having a poor design, it could lead to future problems later on down the line, like adaptability issues. Like imagine you're making some software for Apple, you then try and put it onto a Windows-based machine. The architecture can't cope with that because it wasn't planned properly, so there's bugs in the code, issues, because the design wasn't thought through for these different potentials. So if I zoom out, we've got our waterfall, we've got RAD. Both of those are examples of development which are part of software development in itself. We've looked at the S-curve. We've looked at the potentials of using the S-curve for business, economics, and how it helps a company track the life cycle of a product. In terms of development, though, we've looked at the teams, we've looked at the different steps of development, but let's now look at another model. Let's look at Agile. So with Agile, what happens is it can be done for using what's called extreme programming. And Scrum. So these are two different techniques which are used. Extreme programming, which is basically all about high quality software development, which is quick. So it's about quality, but fast quality. It uses iteration, so it uses iterative. So that basically means it keeps going around in cycles. And the whole point is about teamwork and comms. So you have things like paired programming, people working together, teams. You have frequent releases, so you keep releasing things to get them tested and used. So it's all about test-driven environment. So again, paired programming, test-driven environment, frequent releasing. It's about making something, testing it out, making something, testing it out. So that is extreme programming. Scrum is very similar to extreme programming, but so it's all about teams. So I'm going to do teamwork and I'm going to link it back to Scrum. But it's about breaking a project down, like decomposition, I guess. So project down into small parts called sprints. So you break down a massive project into little parts. Those little parts are called sprints. You then work on it, you release. Work on it, release. Now, basically, you would have different people with different roles whilst working on a sprint, like a manager of that, etc., and your team within that sprint. But very, very similar, as I said. Scrum is more about project management and team than extreme programming. Extreme programming is more prescriptive, where you get your code, you test it, you get your code, you test it, you get your code, you test it. Scrum is more about also adapting to new situations. So both of these are agile techniques. You could use either extreme or Scrum, but there you go, a little bit more background information. Now, when we talk about disadvantages of agile, let me just go up here. We've got things such as pair programming, not popular in the first place. You don't have design documents, that's a concern. So lack of design documents. Lack of deadline. And that makes people feel uncomfortable if there's a lack of a deadline, like customers. The advantage is, so I'm going to do a plus, possible for developing well-written solutions, i.e. code, quickly. So that's an advantage, a plus. We then got Big Bang. What I'm going to do is, let's just do this. So Big Bang is a development method. It's up there with Waterfall, Rad, Agile, and it is all about focusing all resources in the development with little or no programming. No planning. So you can say it's very similar to Agile. Just move up there, move up there. So Big Bang is about just focusing on the programming. And it's great for tiny, repetitive, or you can just do tiny projects or small projects, or repetitive projects, things which you've done many, many times before. If you design online stores to make a checkout for a supermarket online, if you've done loads already, you don't need to do loads of planning. Big Bang's perfect. But, so this is a positive, the negative, high risk. It's high risk and expensive if it goes wrong. So if the requirements are not understood, you could do a whole project and get it wrong. It's expensive, it's bad. Big Bang is very similar to Agile. Agile, as we've established, is also very similar to RAD. But there are some slight differences as we looked at. Agile looks at the Scrum method and the, I just had a brain for extreme programming. It looks, whilst RAD is all about the prototypes, it's great for graphical user interfaces and stuff. Big Bang is all about going straight into the code. Agile is more team-based. Big Bang is just get on with it, do it. Great for projects which you've done before or small projects, but if you get it wrong, oh dear, game over. We then have Spiral. Let's move Spiral all the way out here. Spiral literally is all about risk driven. So how it works, it looks at the risks of a project and adapts. So that means for every project is unique, each project has a risk, so it creates its like own personal solution to it and adapts a team to use one or more process models. So Spiral, you could argue, is another iterative process, but it's more personalized to deal with risks. So what are risks? Let's then create a plan based on these risks. So the positives, adding functions or features later is easy to do. Easier cost management. So as it's all about risk management is easier. As the way Spiral works, it literally just repeats itself as development is repeated. So it's iterative. So every time you repeat a step, you can look at the risks again. Fast development, and you get customer feedback. But the problem with it is time and budget. You might develop a project because you're focusing on the risks and it might have very little risks involved by the end of it, but you might be over budget. It's the best situation for large projects. No point going over and over and over and over and repeating for a tiny project. It's rigid. What that means is strict rules to follow. Different to Agile, different to RAD, different to all of those aspects. And because it's best for large projects, for small projects, it's expensive. We then have one of the big ones, which is changeover. So let me zoom out and let's go over here to changeover. So far, just to recap, we've looked at a heck of a lot of things. We looked at development. We looked at how the S-curve is used to help businesses manage their products, the life cycle of the products, to look at the customers, classify their customers, to do with technology. We then looked at the team around developing a new product. We looked at the steps of developing a new product or project. We looked at the different methods you could use. We're now going to be going right back to the steps, and in our steps, we're going to be looking at release. We're going to be looking at changeover. With changeover, what we've got is parallel. We've got phased. We've got pilot. And we've got direct. Parallel. Old and new systems run at same time. It checks, well, by doing this, for consistency. So you run one system, you run the new system and the old system at the same time. Let's imagine it's booking seats on an airplane. It then looks at the results of both of them and compares them. If the new system's got different results to the old system, the likelihood is the new system is wrong somewhere, so it needs to be tweaked without causing huge harm. So the advantages is going to be if one fails, so if the new system fails, you've still got the backup of the old one running at the same time. It's the safest. It's the safest changeover by far because you've got two systems running at once. If one goes, the other one's still there. The disadvantage is it's a duplication of effort running two systems, and it costs money as well. You're going to have people monitoring both systems. Imagine you've got the airline ticket situation again. You've got old and new system. You're running them both at the same time, but so you need people to check both systems to do the comparisons. So it's really ideal for critical systems, life support systems, etc. So if you're a radar company for airplanes in flight control, and you've made an update, what you'll do is you'll have the old system before the update and the new system with the update running at the same time in parallel. If there's bugs in the new system, you've still got the old system to keep things safe. Critical systems. Why is it just for critical systems? Because it's expensive. It's a resource, it's huge. You've then got phased. Part of new system deployed, rest of old still working. So you release a little bit of a new system at a time. So old is phased out. So if we look at advantages, works well with RAD because you can be using prototypes to be working with old systems. Positive, any issues with the new part, remember you're only doing it one little bit at a time, can be delayed until a fix because you've still got the old system. But the negative is the old system has to be compatible with new. And this isn't the case with everything all the time. Imagine, for example, we've got some old school software sims where we do our registers and stuff like that. It's all done on an app or program. It's not web-based. It has to be installed onto your computer. It then has to be signed in and you get logged into a server, but it's all done through a program, a very old program. Let's imagine there's a new version of Sims being developed, which is all web-based. We can't do this in phased. Let's imagine that a new web-based system allows me to do it in Google Chrome, to do the register and stuff like that. And it's going to eventually replace the old Sims. The issue is that there's going to be some problems with compatibility because this old version wasn't made thinking in mind it's going to be replaced in 20 years' time by a web-based version. Now you could say, when we make the web-based version, we can include aspects of the old system. But then it might not be the best solution for the company to do that. It might be better for them to start again. Therefore, not in every case can we just have a new system being built and the old system being compatible for it to be phased, because remember, phases release something new and we phase out bits of something over time. It might not always be compatible or the correct method to do. That's based on the context. We've then got pilot. New system in full, it's rolled out to a self-contained situation, i.e. a branch. So let's imagine it was a bank. You've got lots of different banks. So let's imagine you've got Butterfield, and you've got Butterfield in location A, B, and C. You just put it into location A. The positive is going to be, this is where I need to tidy this up a little bit. Let's get rid of this. So positive, if one branch using this new system fails or has problems, no others have the same issue. But the negatives, it only works if the branches are identical or near identical. Subway, it would work because each branch in Subway is identical. Each franchise is identical. It would work for banks because each one is identical. But let's imagine that you had a business which owned multiple locations, but you said to the locations, you run it how you want it to be run. It ain't gonna work. Or let's say, for example, for trains in the UK. Each train company is private. So you've got Virgin, you've got East Midlands, and the government makes some software. The problem is that the way Virgin operate is completely different to East Midlands. They have different processes, they have all these different things. Or we can use the same actually for flights, for airlines. To get trains, airlines. It's the same situation. Each airline, so we can have, again, Virgin. We could have Cayman Airways. We can have JetBlue. All of these operate differently. Let's imagine the guys in charge of all the airlines create a software package to do something, I don't know, X. Because each airline is different, you can't say, hey Virgin, you pilot it first and see how it goes for you, and then we'll just release it to the others, because Virgin might use, their operations might be completely different to Cayman Airways, so it might work for Virgin, but for Cayman Airways it might not work. It'll be a failure because they operate completely differently. Therefore, pilot won't be a good method if the different branches are different. It also doesn't work if company has only a few branches. Take Tucker on the island. 2 restaurants. Not worth doing, pilot, if you've only got 2 restaurants. It's just not. It's time consuming in itself. You then have the final one, which is direct. Big Bang. So it's otherwise known as Big Bang, I shall say. Okay. Change to new system immediately. So it works best, so it's positive, if no existing system. But a disadvantage, high risk, it fails. Makes perfect sense. So I'll say it again. The situation is, if something goes wrong, it's a huge risk because you're putting everything into it. Okay, please do see the additional resources on changeover where we have to answer different scenario questions, because that is going to be vital for you. Not just knowing about the different changeovers, but applying them to a scenario. Okay, we've then got our final phase, which is also, you can argue, at release, which is maintenance. Now, maintenance, I need to find some space for maintenance because we've completely ran out. Okay, let's go up north. You've got preventative. We've got corrective. We've got adaptive. And we've got perfective. These are all after you release software. It's about actually being responsible for maintaining the code, etc. Preventative. This is all about regular, scheduled maintenance. Flow, keep coming to my line to keep checking it out all the time, just to see if there's any problems. That's them doing regular maintenance, and the whole point is to prevent unexpected failure. They saw that my internet cable, my fiber optic cable, is being eaten by animals by doing their maintenance, and they fixed it before it caused an issue. That is preventative. Corrective fixes problems as they arise to ensure the product matches the requirements. That's when we've done in development stage corrective maintenance. You program something, you get an error, you fix it. So this is done before release, really. We've then got adaptive. Not only is it about fixing bugs after release, but it's more to do with adding features / functions to changing requirements, to changing external requirements. So example, you release a product, there's changes in law. Let's imagine your product was allowing PayPal, and there's a law saying no more PayPal. You would have to go to every piece of software where you've allowed PayPal for all the companies you made online stores for and disable PayPal. That would be adaptive maintenance. You're changing two requirements. Or let's imagine the business that employed you were happy with the website, everything's working, but then we come to you a few months later saying, hey, can you add this extra feature that allows virtual reality tours of our store? You would then have to code it. That would be adaptive maintenance. You'll be adapting to a change, an external change, a change which isn't you, the program, it's the business in this case, by adding new features. You've then got perfective. So it's the aim of making a perfect system. That's the aim of perfective, which matches the spec or the requirements with no issues. So these would be functional and non-functional requirements, making sure that everything is hunky-dory. And this will be taking place during the life cycle, during the development life cycle. So you can argue that adaptive is after release. You could argue that preventative is after release because you just perform scheduled checks. But corrective is done during development, and you could argue that perfective is during development to make sure that everything is hunky-dory. Each one of these maintenances can be done, and they could all be done for a company. It depends upon the agreement you made. Now, with maintenance, let me just zoom out. What we have is all of these could be related to the examples of maintenance for data, software, and hardware. So, with our data, in fact, what I'm going to do is I'm just going to copy and paste into. So, if we're talking about data maintenance, the whole point is, first of all, we want to clean our data to make sure that there's nothing inaccurate. Imagine someone getting married, changing their last name, but you're still calling them Miss Smith when it's actually now Mrs. Johnson. So it's making sure that your data has nothing inaccurate in it. Quality, to make sure that it's up to date and accurate. So it's not just about cleaning it, it's about ensuring that there's good quality. Remember, data is vital for businesses. If your data is inaccurate, your information will be wrong. All information is generated from data. Operations. Data operations are processes used to complete the daily data-related tasks. So you would need to make sure that everything you're doing, so for example, if it's a registration form on a website, you need to make sure it is working fine. Deduplication, making sure that there's no duplicated data on your system. So that could be people with multiple accounts, which they shouldn't have. It could be a transaction made on a website. It's accidentally duplicated it by mistake, so it's recorded as 2 sales when it should be 1 sale. Deduplication would be all about going through and ensuring that anything duplicated is removed, which then improves the quality. So all of these are interlinked. This will improve the quality of our data. Purging, data which is low quality or unusable. So if someone registers on my website as a@blah.com, I know this is a fake email address, so I'll go through, it might be a bot, and get rid of it. That will be purging to ensure then the quality is maintained. Quality is the most important factor from all of this. Without high quality data, it's meaningless. Meaningless data is inaccurate. We lose money from it. Monitoring. Data monitoring involves KPIs, key performance indicators, to prevent data issues. So, along those grounds, we need to make sure that if we're looking at, for example, how fast it takes for people to buy an item on my website, I need to be monitoring this data in the first place. By me monitoring it, I'll be able to see if there's any issues with the above, which might perform or create data issues. So the whole point is to be preventative. Preventative rather than reactionary. Reactionary, something bad happens, we fix it. A bot makes an account, we fix it. Monitoring is all about stopping it from happening in the first place. So it's monitoring, we're constantly looking at something. Is it going to affect our KPIs? So if you work for me and you're responsible for sales and the data's wrong, it's not your fault, but it affects your job and it affects how much money you're going to get from me as a bonus, you want to make sure that you can trust the KPIs. The KPIs are used to measure success in the first place. So these need to be monitored. So data, remember, turns into information. For data to be useful, it needs to be turned into information so we can actually use it. Therefore, we need to make sure our data is high quality. To make it high quality, we need to cleanse it, we need to perform operations on it. We need to do deduplication, we need to purge the data, and we need to monitor our KPIs to make sure that all the data we're collecting is all of those things, so that we're not going to have any data issues, full stop. We then got software maintenance is all about the code, the program code. The program code will use the data, but it's a code like our if statements and our functions which make things work. And we want to make sure, first of all, it's optimized. That means that it's got as little lines as possible so that it can run really fast. Storage isn't going to take up too much storage, so it's smooth. So we need to make sure our code is optimized. Our graphics, if we're using graphics, are optimized, they're compressed. We need to make sure that we're performing error correcting, i.e. corrective maintenance, to make sure that there's no bugs in our code. We need to be getting rid of features which aren't needed anymore. So for example, let's talk about the PayPal one. PayPal not being wanted anymore, let's say by law, I would have to get rid of that from the code completely. I could leave it in the code but comment it out, which means it's ignored, but it'd still be a part of the code. So getting rid of discarded features which aren't needed anymore, making it organized, making our code optimized, or helps with maintenance, or enhancing existing features, making them better, which would be adaptive maintenance. We've talked about that already. So all of those is to do with software. So we've got data maintenance, which is all to do with the quality of our data, doing checks on it to make sure, and maintaining our data to make sure that it's highest quality. We've then got software maintenance. The final one is hardware maintenance in itself. And hardware is really easy. Hardware is the equipment. So we need to do physical repairs on like our servers, our keyboards, our screens. Optimize our hardware, clean it out. So for example, on my computer, I can do disk defragmenter or disk cleanup. All of these are performing hardware maintenance. It runs my computer quicker. It cleans out my computer to make it run slicker. Contract maintenance, so having people to come in regularly to fix or check my hardware rather than just reacting to an issue, or per incident repair. One or the other. Are you going to have people on a contract, or every time someone breaks, is someone going to come in and fix it? So that's what we're going to take into hardware. Now, all of these are linked together, hardware, software, and data. Without hardware, our software can't work. Without good quality software, we might not get good quality data. Good quality data is needed in order for us to turn that into information, which then can lead to sales. KPIs is important to keep that in mind. Okay, now finally, we're going to look at the advantages and disadvantages of each type of maintenance in itself. So let me just clear this. What we've just looked at are the examples of maintenance. Let me zoom out. So all of these are examples of maintenance. Now we're going to look at the advantages and disadvantages of such maintenance in different contexts. So by performing data maintenance, it should give us better flow between our database and our shop. The database is vital. A database stores all our data centrally that we collect. Our software, like our store, so when I buy something online, it connects to the database. All my products are in the database and it connects to my store. The more optimized this is, the better performance we get for my store. The better performance we get for my store, the more money we get. So improving the data flow between the database objects, i.e. the store, and the database is key. It's vital. But also, Optimizing our database design, so those of you who do computer science, we'll talk about normalization here, means that our database will not only just be faster, it'll have less repeated data, which means less storage. Less storage equals more money that we can save. So by performing data maintenance, not only will our data be high quality data where we can measure KPIs, it also allows for optimization between our database and the store, the database object. So Netflix, the website, would be a database object, and it stores all the movies and TV shows in its databases. So it improves the data flow, but also the organization of our data, which means it'll be faster, less storage, and saves us more money. If we look at software maintenance, it's all about, by doing it well, we reduce costs. Because when we add new features and services, it won't cost us much to do because everything has been organized. It's a mature process which saves us time. By saving us time, it's easy for us to later on add new features. We're prepared to deal with any issues that arise because we're being preventative in itself. But by being preventative, by doing schedules on maintenance, and by being perfective, we're hoping that we're prepared for any issue that could arise. Ensure continuity of your project, well, that will be adaptive maintenance. So it means that it can be ongoing for years to come. Increase security of our data, which will be perfective. So by performing software maintenance, we're ensuring that all our data is going to be secure, which means that we're not going to get sued for data breaches. It then allows us, by doing that, everyone else to focus on the core of the business and not worry about any of those things. So software maintenance brings many advantages. Those advantages are what you see here. So this would be what software maintenance is and examples of software maintenance. These are examples of maintenance types. So maintenance types, examples of things in action, and then benefits. Same with here. Examples of data maintenance in action, benefits. So these are the examples of hardware maintenance. Now let's have a look at the benefit. So these are the benefits of hardware maintenance. You have less equipment going down. Less equipment going down saves us costs because we lose money if things go down. It also saves us costs because we're not having to replace things unexpectedly. Conservation of assets, that basically is saying that it allows us to manage our assets, our hardware, effectively over time because we're performing preventative maintenance at the right times. Improves safety. If things go wrong, we get sued. Equipment efficiency. If equipment goes down, we lose money. Efficiency in itself, if it runs slow, we lose money. Improve reliability. Knowing that you can rely on a piece of equipment without it failing. So think of our school internet. Do you think that in terms of reliability it has a high factor in terms of speed, etc., in terms of efficiency? No, because there's not much reliability, not much trust. I can't focus on the core of my business, which is teaching, because I'm too worried about the internet going down. So all of these are benefits of doing effective hardware maintenance. These are what we mean by hardware maintenance, better relationships. All of those are offsprings of the different types of maintenance, which is perfective, adaptive, corrective, and preventative. So, overall, this video has looked at a heck of a lot. We looked at all of this is about development. This is a start point. All of this is to do with development. All of this. We will talk about UX and UI in a separate video. Keep that in mind. We looked at the roles, we looked at the teams, we looked at the S-curve, we looked at the economic benefits of using an S-curve, we looked at the different types of software development models. We looked at the advantages and disadvantages of them. You might want to perform your own research into this as well and use the resources given to you. This is just an overview. We looked at changeover, which is definitely a big question, which could be in your exam. We looked at parallel, phase pilot, and direct, and where they're used and why they're used. We looked at, if I go down, do we have anything down here? So that's Big Bang. We looked at, if we go north, maintenance. We looked at the different types of maintenance. We looked at software, data, and hardware maintenance and what that means and the tasks and the advantages of those. So all of this is to do with development.